right, y'all. Turn down the lights and put that calculator away. It is time for Sinusoids Part 2. You should recall from a previous time that we really started working on developing this relationship between the unit circle and the sine wave. And so, for example, if I were to pause this little animation and then move the angle on the unit circle to about 3 pi over 4, I should notice that the x value of that point on the sine wave is 3 pi over 4. And of course they have the same height, which is equal to the sine of 3 pi over 4, which is 1 over root 2, or approximately 0.707. Again, hopefully all this stuff is really starting to crystallize and make sense to you. And in the previous video, we looked at this general form of a sinusoid in which we've applied all these transformations, or could apply all these transformations that you should recall from earlier in the course. And of course, if I have a negative sign in front of that a value, then that's a reflection across the x-axis, and a negative sign inside the parentheses is a reflection across the y-axis. This all needs to be very familiar with you. Some new terminology is getting thrown out there in this chapter that we're currently on. So this amplitude, for example, is the absolute value of the A term. It gives us the height of the mountain or the depth of the valleys. And again, it's just the absolute value of A. So it's a new word on a fairly comfortable concept, I hope. Another word that is introduced in this chapter is phase shift, which is just another word for H. So don't get thrown off by the new vocabulary. It's really just referring to old concepts. However, I should take the opportunity to say that when we start talking about period, you're going to start to realize that B is what affects the period. But let me just say it very bluntly here. B itself does not equal the period. It affects the period, but don't think that that B value is the period itself. We'll continue to develop that in this video. So let's go on to our first example. And this is a similar phrasing. This is exactly how you are requested to do some of your homework exercises, and you should expect that you might be requested to do the same thing on a test. We are asked to construct a sinusoid with a period of 8 pi over 3 and an amplitude of 5 that goes through the point -4, 7. Sounds a little bit daunting, but we're going to just break it down in piece by piece and find it's not that bad. Let's start by reminding ourselves of the general. Well, let's just start, how about with the basic sine wave. And I need to recall, I need to know very well that a basic sine wave that I have not transformed in any way yet has a period of 2 pi. And if I ask you, why does it have a period of 2 pi? You should be able to say, oh, that's because it relates to one trip around the unit circle. So let's think of that period that we want it to have of 8 pi over 3. We want it to have an period of 8 pi over 3, which if you deal with the fraction aspect of that, you'll realize that 8 pi over 3 is greater than 2 pi, not by much, but a little bit. So 8 pi over 3 I'm going to put right here. And we realize that we want a sinusoid that has been horizontally stretched. So it should look a little bit more like that. It is a horizontal stretch of the original basic one. So if here's the original, I stretch it out horizontally to 8/3. And I should ask myself, how much is that horizontal stretch? If I take that original period of 2 pi and I multiply it by my horizontal stretch factor, I need to end up with 8 pi over 3. Let me pause for a moment and just mention that you may note that there's a formula in the book for this, but I ask that you resist using that formula. I worry that, I don't know, I feel like we have the tools already to tackle this, and just memorizing a formula, as you well know by now, is not something I am in favor of unless you thoroughly understand why the formula works. So let's start with stuff that we already know, and then eventually I might say, okay, let's use the formula because you understand how it works. So what goes inside that parentheses? What horizontal stretch factor goes inside that parentheses? Hopefully you're saying, well, 2 pi times 4 gives me the numerator, and that denominator of 3 will give me my horizontal stretch factor. So make sure you rewind this, replay this again if you have to. Make sure you thoroughly understand how I got that horizontal stretch factor, because I'm going to erase some of what I've got here just to clear up the screen. Let's take a look at the fact that I want it to have an amplitude of 5. And I think you'll find that one is fairly, I'm hoping you won't have too much trouble with that. If we want the amplitude to be 5, we need to recognize that the basic sine wave or cosine wave has a height of 1, and therefore its amplitude is 1, and we want that to be taller. We want to take that wave that we have now, and this is not really to scale, and my drawing is horrible, I know, but I'm just going for a concept here. We want that height of the mountain to be 5, and we want the depth of the valley to be -5, and therefore have an amplitude of 5, right? So let me start, let me shrink this wording down and start dealing with an equation up here. Since we're applying these transformations, a horizontal stretch, and hopefully you recognize that this 5 that we just dealt with, remember the amplitude is just another fancy way of saying I want a vertical stretch of 5. So I've got a horizontal stretch of 4/3 and a vertical stretch of 5. Let's go ahead and apply that. I know I have another piece of information to deal with, the fact that it goes through this point. But let me take that y equals and rewrite my function here. My basic y equals sine of x. And I'm going to take that horizontal stretch of 4/3 and say, I know that counterintuitively that involves a 3/4 here. And my vertical stretch of 5 intuitively involves a 5 here. So far I'm moving along pretty well. I'm going to once again clear off some of the clutter here. Oops. And the last thing I need to do is to make sure that it goes through the point -4, 7. I hope you're viewing this on a big enough screen where you can see this last little piece of information. I need this to go through the point -4, 7. Now there are multiple ways I could do this, but I'm going to go for the easiest way, the most direct way. So I'm going to acknowledge that the sine wave, even after the horizontal and vertical stretch, it's still going through the origin, right? It still starts at the origin. So I'm going to say, what if I take that point of the curve, and if I were to move it along with the rest of the curve, if I were to move it to the left, smartboard's not working out, not cooperating with me. Okay, if I were to move it to the left 4 and up 7, wouldn't that black point right there be going through the point -4, 7? So again, I know this is not really to scale, but hopefully you're getting the concept. If I move it to the left 4 and up 7, it would go through that point. So again, way out of scale, but if you follow in the concept, -4, and let's say that this is at 7. I'm a little embarrassed by the quality of my graphics here, but I hope you're following the idea. And hopefully you followed that. I want it to go to the left 4 and then up 7. And the way that I would do that is to, let's erase this and put counterintuitively +4 and then +7. And hopefully you see that I have one little last thing that I need to do in that equation. Something that's not quite right yet, and that is I need an extra set of parentheses there. That's that preferred form of the equation. So I apologize for the messiness of this, but I'm just going to hope that I've gotten my point across. That is our sinusoid, and when they say construct a sinusoid, what they really mean is write an equation. There it is. All right, so let's look at one more example, and then I'll have you try on your own. Wouldn't it be nice? I had a student a few years ago who typed this in the calculator, and I never did figure out if it worked for him, but more power to him if it did. All right, another thing you're going to be requested to do is to specify the period and amplitude of a function when you're given its equation. And then when we're given this picture here, you're going to be asked to give the viewing window in which the graph is shown. So use your understanding of transformations. Again, we are not using the calculator here. So let's take a look at this equation. As far as the period goes, we know that this term in here is what horizontally stretches or shrinks a function, and that's the transformation that affects the period. Again, other transformations affect the amplitude or the phase shift, but that 4 pi is not the period itself, but it affects the period. So let's think in terms of our transformations from way back. Is that a horizontal stretch or shrink? Well, it's counterintuitive, right? So let's say that's a horizontal, it looks like a stretch, 4 pi, seems like it's making a number bigger, but it's a horizontal shrink of 1 over 4 pi. So, similar to what we did in the last example, if the original period of a sinusoid is 2 pi, then, and I'm horizontally shrinking it down by 1 over 4 pi, my new period is going to be 2 pi, the original period, times that horizontal shrink factor. And if I'm losing you, you really need to come in and get that cleared up. This is a huge point. We need to understand that that is how I'm going to find the period when I'm thinking of transformations. So hopefully you see that when you multiply that out and simplify, that simplifies to just 1/2. So the period is equal to 1/2. That's part of what you would write down as your answer. And I'm going to erase it up here just so I can move on. But let me get rid of that. And again, I hope I was clear on how you found the period. So I'll at least leave this part up on the screen. And the good news is the amplitude is pretty, again, straightforward. You just say, oh, that's the 8, the vertical stretch there. That gives me my amplitude. And remember, we can ignore that negative sign, or if you prefer, think of taking the absolute value. Let's remember that the amplitude is the absolute value of the A term. So in this case, that's the absolute value of -8, or just 8. That is our amplitude. Now, given that, look at this equation, or I'm sorry, look at this graph, and let's deduce what the window dimensions are. You are being asked to give the viewing window. In other words, what's the x-min, the x-max, the y-min, and the y-max. So this is testing your understanding visually of what a period and an amplitude looks like. So let's do the period first. And I'm going to draw on here one full period of this cosine wave. And I started at the bottom of the valley, so it's going to end at the bottom of the valley. And then I'm going to say, how many of those do I have on the screen? And let me point out too, again, if the period is 1/2, then I know that that is 1/2 on the x-axis. Well, hopefully it's evident to you that I have another period right here, and therefore this value would just be 1, right? And likewise, the x-min would be -1. So again, after you calculate the period, you're using that information and looking at your picture and asking how many periods do I have here in the picture, and that helps you deduce your x-min and your x-max. How about the amplitude? Do you see how that's going to help us find the viewing window, the y-min and the y-max? And I hope you see the trap waiting for you there, that if you were to just count, oh, that's 1, 2, 3, 4, 5. I hope you realize the error of that. That would imply that this height is 4, but we know the amplitude is 8. So we need to recognize that if this has to be 8, that tells us that we are counting by 2s on this along the y-axis. So if I'm counting by 2s, 2, 4, 6, 8, 10, my y-max is 10. Likewise, my y-min is -10, and therefore my viewing window is, my window goes from -1 to 1 by -10, 10. It's getting a little bit cramped here on the screen, but the good news is I'm done with that example, and I hope it made sense. Please come by if it didn't. Your turn. I just put 2 problems on there and have at it. All right, let's take a look at the solutions that I hope you have paused and found for yourself. There is the sinusoid for the first one, and then there's the period, amplitude, and window settings for that second example. If you had any trouble with any part of this lesson, please, you know what to do.